So let us continue. Here input Vi is applied to the pin number 2. So Vi is compared with the V reference that is appearing at pin number 3. So if Vi is greater than V reference, then it gets the output voltage gets saturated to minus V sat. And if input is less than V reference, then the output gets saturated to plus V sat. So this is the principle of working of the Schmitt trigger. Now let us see the design. So to design the Schmitt trigger, UTP and LTP values will be given by the examiner. Okay. So for example, UTP we have assumed plus 6 volts and LTP minus 2 volts. UTP means upper triggering point. Okay. LTP means lower triggering point. Sometimes these are UTP and LTP are also called upper threshold voltage and lower threshold voltage. Okay. So UTP we have assumed plus 6 and LTP we have assumed minus 2 volts. Okay. So from the theory we know the equations. UTP is equal to VR. VR is this DC signal reference. So VR into R1 divided by R1 plus R2 plus V saturate into R2 divided by R1 plus R2. This is the formula of UTP. Similarly, the formula of LTP is given by VR into R1 divided by R1 plus R2 minus V sat into R2 divided by R1 plus R2. Now call these as equations 1 and 2. Now first let us add both the equations, that is UTP plus LTP. So when you add both the equations, here plus is there, minus is there. So these two terms get cancelled and we get twice of VR into R1 divided by R1 plus R2. If you observe, the terms are similar. Okay. So when you add, this is plus sign, this is minus sign. Therefore, these two terms get cancelled and we get twice of this much. So, twice of VR into R1 divided by R1 plus R2. Call this as equation 3. Now, UTP minus LTP. Let us subtract equation 1 and 2. So, subtracting, here subtraction means this remains plus plus. Here this becomes minus and here minus of minus becomes plus. Therefore, first and this term, these two, first and third term get cancelled and here we get plus and here also minus of minus we get plus. So we get twice of V sat into R2 divided by R1 plus R2. Call this as equation 4. Now let us substitute the values in equation 3 and 4. That is UTP we have assumed plus 6 and LTP minus 2. So 6 minus 2. 6 minus 2 is nothing but 4. 4 is equal to twice VR into R1 divided by R1 plus R2. Here this 2, I have brought this to the denominator of the left hand side. Okay. So 2 here 4. 4 by 2 is nothing but 2. So 2 equals VR into R1 divided by R1 plus R2. Call this as equation 5. Now from equation 4, that is UTP minus LTP. UTP is 6 minus LTP is minus 2. So 6 minus of minus 2. So it minus minus becomes plus. 6 plus 2 is 8. So 8 equals twice the V sat into R2 divided by R1 plus R2. Now 8 divided by 2 is equal to 4. So 4 is equal to V sat into R2 divided by R1 plus R2. Call this as equation 6. Now here we know that V sat clamps at plus 12 volts. Okay, plus V sat is equal to plus 12 volts. That is the plus VCC. Okay, plus V sat is equal to plus VCC. So V sat is equal to plus 12 volts and R2 we assume. Okay, assume the value of R2 as 10 kilo ohm. Okay. So now substitute the values of V sat and R2 here. So now what you will get, 4 equals plus 12 into 10k divided by R1 plus 10k, and simplify this equation for R1. So we get R1 value as 20 kilo ohm. but the standard value available is 22 kilo ohm. So choose R1 equals 22 kilo ohm. So R1 we have chosen here 22 kilo ohm. Okay. Now from equation 5, in this equation, now we know the values of R1 and R2. That is R1 is 22k and R2 we have assumed 10k. So substitute the values of R1 and R2. This side we have 2, so we can determine the value of VR. So simplifying this equation, we get VR approximately equal to 3 volts. That is, we get 2.9, which is approximately equal to 3 volts we get. So this is the value of VR. So here DC voltage we are providing 3 volts and R2 value is 10k, R1 is 22 kilo ohm. So this is how we design the values of all the components here. Now let us see the waveforms, input and output waveforms. See, this is the input. Input is the sine wave. Okay. So see, the amplitude of the input should be greater than the UTP and LTP values. Okay. So UTP we have assumed plus 6. Plus 6 means this is the origin. So from 0 above plus 6. Okay. So if UTP is plus 6, input should be greater than plus 6 you have to apply. So I have assumed the positive peak as plus 12. So, and LTP is minus 2. Minus 2 means it is below 0. So suppose it is minus 2, LTP is here minus 2. Then in the negative side also it should be greater than minus 2. Here also I assume minus 10. That means I have applied 20 volts peak to peak voltage. Okay, so positive peak plus 10, negative peak minus 10. So 20 volts peak to peak input voltage is applied and frequency is 1 kilohertz. Now to draw the output waveform, mark the UTP and LTP here. Okay, so drag the lines here from UTP and LTP. See, this is UTP. From here we have to place the dotted lines and LTP here like this. Okay, so UTP, LTP like this. So we know that when Vi is greater than V reference, V0 should be minus Vsat. Minus Vsat means minus 12. Okay, so here input is increasing. Okay, so input is greater than, when it becomes greater than V reference, it should clamp to minus Vsat. Here you can observe when Vin becomes greater than this, it gets clamped to minus Vsat. Similarly, when Vi is less than V reference in the sense here, this portion, okay, when it is less than V reference, it gets saturated to plus Vsat. So it gets saturated to plus Vsat. So like this, the output we get a square wave. Okay. Now next is the hysteresis. So hysteresis is nothing but the transfer characteristics. Okay. So transfer characteristics is nothing but the plot of V0 versus Vi, output versus input voltage here. So when we obtain the hysteresis curve, that is we used to press X and Y button in the CRO, that I will show you. So when I press that, we can obtain the hysteresis plot here. So this is the hysteresis plot. Here you need to measure the UTP and LTP. That is, here is the 0 origin. From 0 it is how many divisions. Okay. So this will give you the UTP. Now we should get plus 6 volts. Okay. And LTP we should get minus 2 volts. Okay. So from here to here we need to measure. So when we measure we should get minus 2. So it should satisfy the theoretical design. Okay. So this is about the design of the Schmitt trigger. Now let us move to the experiment. So I have already rigged up the circuit. Okay. So you can observe here, this is the circuit of the Schmitt trigger. Okay, so mu A741 op amp is used. You can observe here I have inserted the op amp in this socket. So corresponding to this socket, the input terminals are these two. Okay, so in the springboard, on the springboard it will be marked input 1, input 2. So input 1 is the pin number 2 and input 2 is the pin number 3. Okay, so input 2 should be provided with the input here. You can observe for pin number 2 is provided with the input signal from the signal generator. So you can observe here, input I have connected from the signal generator. I have given here frequency 1 kilohertz. Okay, so frequency 1 kilohertz is provided. And you can observe the signal here. The signal applied is the AC signal, that is the sine wave. Sine wave is applied. So input should be 10 volts peak to peak. Okay. So you can observe here I have kept the volt per division at 5. Okay. So 5, and this I will make 4 divisions. Okay. So 4, approximate is 4. So 4 into 5 gives 20 volt peak to peak. So I have applied 20 volt peak to peak input with frequency 1 kilohertz. Okay. Then to the pin number 3, R1 and R2 should be connected. R1 is 22 kilo ohm, R2 is 10K, and VR should be 3 volts. Okay. So you can observe here, from pin number 3 I have connected 22K. Okay, so then 10K, for 10K one end I have connected to the power supply. Okay, and I have provided 3 volts here. Okay, see here the positive is connected to the 10 kilo ohm. Okay, negative is connected to the common ground here, and op amp should be provided with plus 12 volts. So you can observe here plus 12 is given to plus VCC here, and minus 12 is given to this knob, that is minus VCC, minus 12, and this ground I have connected to this terminal, ground terminal. One more wire you need to connect from this ground terminal to the common ground of the circuit. Okay. Here you should not forget to connect one end of R1 to the output, that is pin number 6. You can observe here. So this R1 22K one end I have connected to the pin number 6. Okay. So the circuit is over now. So let us see the waveform.